start with the first.
Okay.
Perfect.
So let me share.
The floor is yours. We can
Yes.
welcome the participant now.
Yes, I'm trying to find the file. Wait a minute. Sorry.
Yeah, in the meantime, you can say that, today we have 3 presentations. And the first one is about the second consultation round here. And then we have 2 more presentations about, the use of broiler litter in anaerobic digestions and water management and saving in broiler farming.
So can you see my screen right now?
Yeah, sure.
Is it
The
in
floor
presentation
is
mode?
yours.
Okay. So thank you, everybody. Welcome again to this meeting today. We are really pleased to have you with us today. And today we are going to discuss actually 2 topics, as Paolo already said. So managing manure and water for sustainable broiler farming. So this is, as you can see, the today's agenda. So I will give you an overview and the main findings from the second consultation round of the BroilerNet project. And then there will be a presentation by Mirko Garuti related to the use of broiler litter in anaerobic digestion, and then a presentation by Paolo Ferrari related to water management and saving in broiler farming. At the end of these discussions, there will be an interactive question and answer session. So please, if you have anything to say or questions related to these topics, just write down in the chat. We will talk about later. And yes, so today we are going to share actually knowledge and explore innovative ideas, solutions, and strategies, as you will see. So I present myself. I'm Annunziata Palamara. I'm a researcher and I work for CRPA, which stands for Research Center for Animal Production, based in Reggio Emilia in the northern Italy. So today I'm going to present you the BroilerNet project. So you may ask yourself, what's this project? Well, it's a EU-funded project under the Horizon Europe program, and it is coordinated by the Swedish University of Agricultural Sciences. This project has been running since August 2022, and it will end next year in July 2026. So as you already know, this sector, the broiler sector, is facing an increase in market demand, and it is really important to meet that demand. So that's why this project wants to face three dimension of this sector. So this project wants to address emerging challenges in poultry production in an integrated way. So it pays particular attention to 3 key dimensions. So as you can see, environmental sustainability, animal welfare, and health management. However, this project has another key objective, and it is to reinforce collaboration among all stakeholders in the supply chain. So I'm talking about researchers, farmers, technicians, companies, and policymakers. So what the BroilerNet project wants is to promote continuous exchange of information and expertise to support innovation and practical improvements. So as we are doing today. It is clear that the transition of the European poultry sector requires the adoption of more sustainable, health-oriented, and welfare-friendly systems supported by innovation, farmer empowerment, and collaborative approaches. So what are the major concerns that the BroilerNet, the broiler sector needs to face? Well, here you can read some of the main concerns related to environmental impacts. Of course, there are high greenhouse gas emissions, intensive use of land and water, and pollution, for example. Related to animal health risk, there is the high density increases disease transmission and the addiction on antibiotics. As you know, these problems are really related to the antimicrobial resistance. Finally, the animal welfare concerns. These These concerns are related to limited expression of natural behaviors and stress factor. The customer today is really care about the ethical characteristics, the ethical aspects of the products. So it is really important to meet that request from them. So here you can see the partners of this project. There are 25 organizations between research and innovation bodies, and also representative of the livestock sector for each country. And in this project are involved 13 countries. So for each country, there is a group of national experts, and they are in charge to point out the national needs of their own country. But before talking about what they do, it is important to say who they are. So in this project, there are 3 groups of people. As you can see, there are the BNFs, the beans, and the TANs. The BNF, so it stands for Broiler Network Facilitators. They are in charge to collect good practices from farms, support knowledge exchange. So they talk with the farmers, collect the good practices, and organize the exchange of information. Related to the beans, this stands for Broiler Innovation Networks. So we are talking about national poultry expert groups, and they're in charge to propose new challenges related to the needs of their own country, and also then to propose a solution related to the challenges, and they work on a national level. Then finally, there are the TANs. They are thematic expert networks, and they work on an international level. So their duty is to select key challenges proposed by the beans, and then identify the winners, so the BroilerNet champions. Here you can see the scheme, so the structure of how they work together. So firstly, they find the national needs. So the beans propose these challenges and to the TANs. Then the TANs select the key challenges that they think they are the most important, and then the beans related to the challenges propose good practices, and the really key information is that these good practices are based on real farm data. So these good practices are not just theory or just fantasies, so they are based on real data. So if I want to adopt these good practices, I already know that somebody already did that. So that's a good characteristic of the output of this project. So then, after being proposed these good practices, let us evaluate these good practices and choose the winner. So we have finally the broiler champions. So this scheme, we do that for 3 consultation rounds, as you can see, per 3 times. And it's related, of course, we find 3 challenges for each consultation round related to environmental sustainability, animal welfare, and animal health, for a total of 9 challenges per year. Here are the outputs of the second consultation round. Related to environmental sustainability, what we had to face this year was related to improving water management, water saving and management, improving manure and farm waste management, and then assessing and minimizing the environmental footprint of meat from slow-growing strains. Today, I have to say, we are not gonna talk about these good practices. Maybe Paolo will talk about the first one, so EcoRain Ultra. But if you want to learn more about these good practices, you can find this type of document, as you can see in the slides. So they are fact sheet, and here you can find all the information related to these good practices. Also, the info of the farmer, if you want to talk with him, to them, and I don't know, find more information. This type of document, you can find anything on our website. Here you can scan the QR code if you want to learn more. And in this website, you can find best practices and hands-on tools. There are more than 100 good practices. And as the previous one, as what I showed you in the previous slide, then you also find news and event updates like this one. And you will also find information about our upcoming webinar, for example, to be held in February. I'm trying to some advertisement now. So the main topic is low-growing broilers in our next webinar, and carbon footprint calculation. So, but more details will be available on our website in the coming days. So please stay updated. Moreover, on our website, you can find multilingual resources. Of course, anything is in English, but you can find also documents or good practices in your language, in mother tongue. So please, if you want to learn more, just feel free to scan this QR code, to visit our website, or also contact me to my, just write me to my email. So my presentation, it's done. I think I can finish. So please, if you have any questions related to my presentation, just feel free to write down in the chat. And I think we can move on right now, maybe. So now it's time to dive into the core of this webinar. So I'm pleased to welcome Mirko Garuti. You can present yourself and share your presentation. So Mirko, the stage is yours right now.
Thank you, Tina, for the invitation and the collaboration in such kind of activity related to the BroilerNet project. I gently ask to you to stop your presentation in order to share mine.
I think you can share your screen.
Yeah. Okay. Now it's possible. Okay, I think you can show my presentation now.
Yeah, that's okay.
Thank you. I'm Mirko Garuti. I'm the head of Energy and Environment Department in Research Center for Animal Production. I work on biogas sector since 2011, and the presentation of today is focused on the utilization of broiler litter in anaerobic digestion. We have to start to focus about the problem, because in the world we need the animals, because they are playing a crucial role providing protein sources and promoting the global food security. Anyway, manure is one of the most important and consistent organic waste originated from the farming of chicken, and the improper utilization of manure on the land could lead to greenhouse gases emission, ammonia emission, and potential contamination of water bodies due to nitrate leaching. The waste worth is a waste management strategies to aim at the recovery of add value to waste stream through new technology, job creation, and environmental benefit. It's important, of course, to investigate how technologies are cost effective and are technical, have the technical possibility for a scale up to industrial scale. We can start with the composting technology. The composting technology is an anaerobic stabilization of broiler litter with the aim to reduce odor emission, ammonia emission, and produce biofertilizer to use on the land for fertilization of the soil. We have a greenhouse gases saving because by the use of biofertilizer, we can avoid to produce and use chemical fertilizer. Only two photos from the previous webinar performed last July. We have a best practice example in Italy of agrofertile company, where the aerobic stabilization of broiler litter were done in a big treatment plant, where the broiler litter is aerobic stabilized, and the ammonia and the exhaust gases from the treatment plant are treated in acid scrubber to remove ammonia and dust, and in biofiltration system to remove ammonia, volatile organic compound, and odors. This kind of treatment plant is performed with a screening part, and at the end of the process, a pelletizing, a drying, and packaging of the final product in order to obtain biofertilizers. Some picture of the treatment plant, where the broiler litter is composted, the biofilter system for the reduction of odors and ammonia emission, and last, the packaging system to produce the final biofertilizer. There are other technology to valorize the broiler litter, like combustion, pyrolysis, and gasification. We can obtain benefit from bioenergy production to produce renewable heat, thermal energy, and biofuel, and environmental benefits like reducing the odor emission and ammonia emission, avoiding fossil fuel energy production. For such kind of technology, for example, in Italy, we don't have a large spread of such kind of technology, but I want to give an overview of the most innovative system, because combustion is the valorization of broiler litter in presence of oxygen. Pyrolysis and gasification are other technology with a minor use of oxygen, or better, a controlled utilization of oxygen during the transformation of broiler litter in thermal energy. From the pyrolysis, we can obtain also other product at the end of the process, like biochar. And from gasification, we also can obtain a syngas rich in hydrogen and in a minor part of methane. We can jump in the core of the topic of my presentation, the valorization of broiler litter through anaerobic digestion. From anaerobic digestion, we can obtain biogas, and with biogas we can produce thermal and electrical energy, but also biomethane for the utilization in transport. From an environmental point of view, through anaerobic digestion, we can obtain the reducing of odor emission, the reducing of ammonia emission, because the manure is not put directly on the land, but is treated in the anaerobic digester. We produce digestate, and the correct utilization of digestate on the land promote the uptake of ammonium for plants. And at the end of the process, we can also have a strong greenhouse gas emission reduction, with avoid chemical fertilizer production, of course, and with avoided fossil energy production and utilization. Anaerobic digestion is one of the most significant example of circular economy. We can start from biomass. The biomass are made by organic material, manure, energy crop, agro-industrial byproduct, but also bio-waste. We can put the biomasses into the anaerobic digester, where microbes and anaerobic bacteria break down the organic matter, producing two important streams. The first one is the biogas. The biogas can be utilized in combined heat and power unit to produce electrical and thermal energy, or biogas can be upgraded to biomethane, dividing the carbon dioxide and the methane. The methane can be injected in the gas grid or liquefied to liquid biomethane. The other important product of anaerobic digestion is the digestate, is the effluent process, and can be directly used on the land for fertilization of the crops. Only few numbers about the European biogas sector. In 2023, in Europe, there were more or less 21,000 of anaerobic digestion plant between biogas production and biomethane production. And such kind of numbers are increasing year by year. We also, the European Biogas Association, perform a sort of prevision of biomethane potential in Europe, and the potential amount of biomethane is more or less about 35 billion of cubic meters in 2030, and 91 billion of cubic meters from anaerobic digestion up to 2050. Where biogas is produced, each country have a particularity, and there are several feedstocks that the country can use for biogas production. For example, in Italy, there is a major share of manure to produce biogas and biomethane. In other country, like Germany, the utilization of other substrate like agricultural residues and energy crop are made a different biogas and biomethane, impacting on the calculation of biomethane sustainability. About Italy, Italy is one of the top country for biogas and biomethane production in Europe. We have a strong regulatory framework and support scheme framework to promote the biogas production for electrical energy, but also the biomethane production for transportation uses and industrial uses. Just to give you a few numbers, after the 5 last tenders in 2025, a total of more or less 575 projects for biomethane are attending in this period, and we have more or less 2 years to transform the project in a real installation. And 95% of such kind of new installation comes from the utilization of agri-based feedstock. What about broiler litter? Broiler litter is a useful and important agri-based feedstock for biogas and biomethane production. This table resume a monitoring activity of a broiler litter sampled in a different part of the chicken farming. And the most important chemical characteristic for biogas production are shown in this table. I want to underline the total solid content of a broiler litter with an average value of 65%, and the nitrogen content with an average value about of 6% expressed on the total solid, because the quantity of total solid and volatile solid impact directly on the biogas production. More is the total solid content, and more is the biogas and biomethane production from 1 ton of wet weight of broiler litter. It's also important to understand how much broiler litter will be produced in the chicken farming, and we evaluate an average estimation, an average number of 5.5 kilogram of total solid for place year in the monitoring activity. There is also another aspect to consider when you want to digest the broiler litter, like the other agri-based feedstock. It's important to know how much biogas will be produced from such kind of material. This to solve this issue, it's possible to make a laboratory analysis called a biochemical methane potential test in order to simulate the anaerobic digestion process at lab scale and to obtain the amount of biogas produced. This picture shows the system that we realized during the last 15 years to give an answer to the farmer, to the research project, and other company about the quantification of methane production from agri-based feedstock. From an internal survey of biogas and biomethane production of broiler litter, we measured an average total content, an average concentration of total solid in broiler litter about of 57%. And the specific biomethane production reach an average value of 250, expressed as normal cubic meter of methane for ton of volatile solid. But when you take your broiler litter and put in the anaerobic digester, you can express the same number in another unit measure, like a normal cubic meter of biomethane for ton of feedstock. Such kind of number is very huge for a biogas producer, because it's comparable with the production of 1 ton of maize silage, and very energetic energy crop used for biogas production. There is also a huge variability in the biogas production of broiler litter, and it depends from several aspects. One of such kind of aspect is the quantity of straw inside the broiler litter. This graph shows the specific methane production of 2 kinds of sample of broiler litter. One of this with the green line have a huge amount of straw inside. Anyway, the point is before to start to produce or to realize a biogas system or a biomethane project, it's better analyze the specific manure from the chicken farming in order to make a very accurate sizing of the project before the startup and before the realization. We can have a fast look inside the biochemical reaction of anaerobic digestion. The anaerobic digestion is characterized by 4 microbial phases: the hydrolysis, the acidogenesis, the acetogenesis, and the methanogenesis. During this microbial phases, a lot of volatile fatty acids were produced from the breakdown of organic matter. If some inhibitory situation occur during the anaerobic digestion process, the accumulation of volatile fatty acids leads to the inhibition and to the decrease of biogas production. The other part of the story is the digestate. During the anaerobic digestion, you produce biogas, but you produce also the digestate. And the digestate at the end of the process contain the nitrogen, the nutritive element of the original feedstock, but also the poorly degradable organic fraction that you can use to the soil to increase the carbon level of the land. The anaerobic digestion is a very complex system where the biology, the biotechnological part, the technological aspect of the biogas plant are very interrelated and connected. For such kind of reason, it's important to understand one aspect of the digestion of broiler litter related to the ammonia, the nitrogen concentration. During the anaerobic digestion, the nitrogen is converted in ammonia, and ammonia have a chemical equilibrium between the gaseous form and the liquid form in ammonium. There are chemical aspects that regulate such kind of equilibrium, and temperature and pH play a crucial role in the equilibrium between ammonia and ammonium. The point is that ammonia is a strong inhibitory compound for anaerobic bacteria, and it's important to find the solution to avoid the decrease of biogas production and to maintain a healthy system of an anaerobic digestion. For example, it's common know from the literature and from real cases that a concentration below of 3,500 milligram per kilo of ammonium is a condition for healthy mesophilic anaerobic digestion. I want to show you a real case monitoring of anaerobic digestion of broiler litter in co-digestion with other agri-based feedstock. In this biogas plant, the biogas is recovered to obtain an electrical energy power of more or less 1 megawatt. The chemical analysis were performed on each feedstock, and there was a daily recording of the feedstock used for bioenergy production and a continuative monitoring of biological processes. This gives us the possibility also to create a predictive models to manage and to optimize the biology inside the digester. This graph shows the share of biomethane production from each feedstock during a period more or less of 2 years. The feedstock are broiler litter, energy crop, agro-industrial byproduct, and olive pomace. The co-digestion of broiler litter and olive pomace lead to a good equilibrium between carbon and nitrogen in the table feeding of the biogas plant. Anyway, the biogas plant operator want to substitute a quantity of energy crops with a broiler litter, introducing it step by step during the next period. In such kind of changement of the table feeding, we observed an increase in the ammonium concentration inside the digester. In this graph, there is a concentration of ammonium inside the digester, but also the concentration of organic acid, like acetic acid and propionic acid. When acetic acid and propionic acid reach a high concentration, the biological process leads to a failure. During the startup and the introduction of broiler litter in the digesters, the ammonium concentration will grow up week by week, but there is a moment when the acetic acid concentration is too high, and it was important to stop the feeding of broiler litter and to start some kind of countermeasure to recovery the biogas production. In this point, the concentration of acetic acid show an inhibitory condition reaching 3,500 milligram per kilo of ammonium inside the digester. After an adaptation period, the utilization of trace element and the dilution with other agri-based feedstock, the equilibrium of the system was recovered, and the utilization of broiler litter was possible with the increasing quantity for biogas production. In a second moment of the monitoring activity, we reach another inhibitory condition, but in that case, the inhibitory condition was due to a higher ammonium concentration inside the digester. And with such kind of example, I want to show you how the anaerobic microbes can be adapted during the time to increasing ammonium concentration inside the digester. Three take-home message from my presentation. Chicken manure have a high biomethane potential to produce bioenergy, but there are some challenge to take in consideration. Anyway, the water dilution, the co-digestion, the natural adaptation, but also the utilization of biotechnological strategies like addition of trace metals represent a possibility to overcome the ammonia inhibition. And besides the bioenergy production, anaerobic digestion of broiler litter offers also environmental benefits through the digestate utilization and the greenhouse gases savings, contributing to the overall sustainability of the poultry farming. I want to thank you for the audience, and I'm also available for give an answer to any question.
Okay, so thank you, Mirko. We really appreciate your presentation. Thank you for sharing your valuable insights. Now, to guide us through the next point, I'm pleased to welcome Paolo Ferrari. So, Paolo, if you want to present yourself and share your screen. Open your mic also. the mic, Paolo, the microphone.
If I share the presentation, I'm not able to activate the mic anymore. So now I will
Really?
share again.
Okay. Okay.
Do you see it in presentation mode?
That's not in presentation mode.
Is in presentation mode?
No.
Now it should be.
No. Oh, yes.
Okay.
Yes. Okay.
Good. Thank you, Tina. Yes, I'm Paolo Ferrari, and together with Tina, I am leader of the Work Package 2 Environmental Sustainability of the BroilerNet thematic network. And I would like to thank you, Mirko, for the very interesting presentation. And now we are going to switch to another topic, which is, it is a very important topic. Just to mention the European Water Resilience Strategy, that is a document that was issued in June this year. Water is, just to mention, water is life. Our environment, economy, our food and energy security, and our quality of life rely on a stable supply of water of the right quality. And according to this document, today we can no longer take water for granted, and this affects citizens, business, and the environment. So nowadays, water resilience is a matter of security and crisis preparedness for the EU, as water is a basic need and a critical resource. So, investing in sustainable water management and innovation will strengthen Europe's business and boost competitiveness, even in the broiler sector. So, poultry farming, so like other forms of agriculture, requires large amount of water to meet the direct consumption needs of the animals. So for feed production, of course, but also for watering them, and also for cooling, particularly in the southern European regions, and for cleaning and disinfecting the facilities at the end of each production cycles. So water not optimized use can result in a waste of valuable resources, especially in regions that already suffer from water stress and are vulnerable to the effects of climate change. So particularly in those regions which are located in the south of Europe, in recent times, recent years, the lack of water of enough quantity of quality was an issue during the hot season in summertime. And this is traditionally a problem in the south of Spain, in the south of Italy, in the south of Greece, but it has become a problem even in some more northern regions, like in the north of Italy or some parts of France, for instance. And so this is something that every broiler farmer should take into consideration. If we look in the south of Spain, it is quite normal to see in the livestock farms to have tanks for water to provide self-sufficiency for at least 3 months during the summer period. This year was particularly lucky in that regions because they get a lot of rain, as also in Italy. But in the previous years, it was becoming a big problem, big issue, even in some northern areas. So water is essential, of course, for the broiler growth, health, and farm hygiene. Is one of the most used resources. But climate change has created new challenges, such as increasing the Earth's temperature with a significant fluctuation in the amount of distribution of rainfall, leading to water scarcity. And so we need efficient systems to improve productivity and to reduce waste. Broader water consumption varies with the age, temperature, and feed type. Of course, hot climates increase water intake, and the water to feed ratio at 21 Celsius degrees is between 1.6 and 1.8 in fast-growing broilers, according to the handbook of Avigen for Ross 308. And health issues, but it can be higher in slow-growing strains because, of course, they have a longer period and a little bit higher. Could be this ratio. And health issues can be early detected by monitoring water consumption. This is something that most modern farms already do. And we can see also in the picture on your right. So we have a monitoring of the average feed intake and water intake. So we can check if this ratio is maintained or there is an imbalance, and meaning that there is maybe a leakage of water in the drinking lines, and this leakage should be solved very, very soon, the same day of noticing it, in order to preserve the quality of the litter also, and the ammonia emission, and the health of the animals, and the welfare, and so on. So, what are the main water sources for broiler farm? One of the most used are wells or boreholes or natural springs. And if you have water of good quality from the source, this is very good because after building the well, the water is for free, so there's no cost. But you have to monitor the quality of the water. But if you have a good quality, you can have some variation. But what is good here is to have a quite constant quality and quantity of water, even if there could be some variation, however. But for sure, we will have more stable quality and quantity than taking the water from surface water, rivers, or even ponds. And in that case, the quality will be changing during the year. Municipal water supply is very good because it is already controlled by the municipal body, but it is more expensive. And in recent years, also some municipalities have problems in southern regions, also due to the lack of water, and also this could be a problem for a farmer. So, in order to ensure the self-sufficiency of water across the year, it is recommended to have a double source. If you have municipal water, you are recommended as a farmer to have a double source in order to be more self-sufficient. And another source could be rainwater harvesting, and we're talking about that later on when we will talk about the winner of the BroilerNet Championship. Rainwater harvesting comes for free, of course, so we can collect from the roof, but it can be contaminated by polluant, by fine dust particles, and so it needs to be treated before delivering it to the broiler. And also there is health biosecurity problems. You know, the avian flu is spreading across the world, and the wild birds can come on the roof also, and it can contaminate the water. So the water coming from rain should be treated very well. And when we, as regards water quality requirements, of course, you can see a table on your right, taken from the Avian handbook. And of course, the pH should be somehow constant in between these two values, 6.5 and 8.5, free of contaminants, bacteria, viruses, and heavy metals, no harmful chemical residues, low turbidity, and it should be tested regularly. Common water quality problems are bacterial contamination, E. coli, Salmonella, but particularly avian flu virus, and high mineral levels like iron, manganese, or nitrates. Biofilm inside the drinking lines, so it is important to control the quality of the water at the end of the drinking lines and in the inlet. In this way, you will check the quality in the inlet, coming from the well, for instance, and you compare it with the water that you have monitored at the end of the drinking lines, because maybe there are some contamination in the pipes. And so it is very important to control this. And also a pH imbalance can affect the equipment, also the duration and the maintenance, and also the medication effectiveness. What kind of water treatment are used usually? First, for mechanical filtration to remove all the particles and suspended particles in the water. And this can be done with sand filters or Campbell filters or cartridge filters. And depending of the flow, there are many. You can see on your left there is a picture, but it depends, of course, on the kind. It is very important to have the quality of the water, and according to that, you can decide about the treatment. Biological filtration is a filtration using bacteria that are able to remove ammonia, for instance, or nitrates, and particularly if you have a contamination with the nitrogen compounds, biological filtration is particularly suggested. And then we have the chemical filtration, which is needed for disinfection. And so we can use chlorination, hydrogen peroxide, or UV ray oxidation with the production of ozone, or acid fires also can be used for that. And this is the last, of course, treatment that you can use once you have removed the organic matter, the other compounds. At the end, you have some clean water, but there are some bacteria or viruses, so chemical filtration is done at the end. The water distribution systems are usually the most common ones and are nipple drinkers, and which are preferred for hygiene and reduced spillage. Bed drinkers are old systems but require regular cleaning. It is very important to maintain the correct height and pressure according to the age of the birds, and to avoid the leaks and stagnant water areas. So water leaks should be controlled and solved as soon as possible. So also drip trays, as you can see, can be used also to reduce leakage, which should be promptly fixed. Uh, Water meters are very useful for monitoring those leakages. And you can put also some alarm systems to be noticed as soon as possible. And also other water saving strategies are the use of high efficiency cleaning systems and to have also smooth flooring in order to the use of high pressures water for cleaning, of course, and rainwater harvesting for cleaning purposes. However, the disinfection is very, very important. The tanks for storing the water should be sanitized regularly. Wild boars and rodents should be prevented from accessing the water sources. And so they should be maintained covered to maintain the quality of the water there. So, as we said, it is very important to record the water usage and to compare regularly the consumption with the expected values. And abnormal matter patterns may indicate disease onset or water leakages or feed issues or heat stress. So this is a very important parameter to be monitored. What are the environmental economic benefits of good water management? Reduced water bills. So you reduce the usage. So if you buy water from the municipal plant, so you have to pay. So if you reduce the water, or even if you get some water from other sources, yeah, you will save some money. Low energy consumption for pumping, less little moisture, better flock health and welfare, reduced ammonia emissions from dry litter, and sustainable resource use. So in our second consultation round, we selected, so the experts of the thematic group for environmental sustainability selected 5 top good practices. And one is related to the water hygiene from Finland. One from France was awarded as the winner. And with a system, a treatment line was proposed. The name is EcoRain Ultra. And I will provide you some more figures about it. The third one was adapted drinker and regular maintenance of the drinkers and water lines, flooring and coating to improve shed washing from Italy, and the use of water meter per poultry house from France. So this EcoRain Ultra plant is about rainwater collection and treatment for drinking and washing purposes. It was proposed last year and presented and awarded at the French fair SPAS that took place in Rennes, Brittany, and the north of France. And this treatment line is composed by mechanical and chemical pre-treatment. Then we have a skid ultrafiltration, which is a pre-packaged, compact and automated system for ultrafiltration. So we have a membrane that is able to remove particles larger than 0.015 micron. So particularly effective for bacteria and viruses, so the smallest particles. And it is possible to make the chlorination in order to have an additional bacteriological protection. And we have also a storage whose capacity is according to the roof area and the local rainfall, enabling a surface efficiency of from 30 to 80% of in water supply. And this is a system that is particularly suitable and suggestible for working capacity operability of over 10 square meters, cubic meters per day. So for large farms. This system can mix rainwater with borehole water or municipal water to ensure farm self-sufficiency based on the roof size, the size rainfall over the last 10 years, and is able to reduce dependency on the public water supply, and groundwater is achieved during drought condition, leading to saving on the cost per cubic meter of water. This is the most suitable for large-scale operation with more than 4,000 square meters of roofing, which is about 3-4 large poultry houses. And some data about the costs and benefits. So the investment for this kind of plant is between 80 and 100,000 euro. And if it is subsidized at 40% by the Rural Development Plan, it translates into an annual cost of from 5,000 to 6,000 euro over 10 years, excluding the interests. Given the average price of 2.5 euro per cubic meter for public water in France in 2024, it becomes economically viable when treating at least 2,000 cubic meters of rainwater annually. And however, we should also take into consideration the maintenance cost, which are about 0.91 euro per cubic meter of treated water from rainfall. So what we can say is that there is an investment because 80,000 euro or 100,000 euro is quite big investments, but is suitable for those farms which are located in areas where droughts can come or has become serious problems in the recent years. So, and the rainfall collection and treatment should be considered as one of the sources of water that you can get. And so it is a valuable investment in the areas where this can become an issue that could stop or reduce the activity of broiler farms during summer months. So thanks a lot for your attention, and so we are prepared to reply to your questions. You can put maybe, I don't know if there is some questions in the chat. Tina, please, could you check it?
Yeah, thank you, Paolo, for this presentation. By the way, there are no questions for now, but maybe someone have, I don't know, questions, also thoughts about that. Maybe someone want to add something. No, you're free to go. Anybody. That's your time.
Okay, I'm checking it as well. I don't see any questions.
Yeah, also, they want the presentation, but I'll send you everything by email, but you can go to our website. I'll leave you there, the website. So you'll find the presentation on our website. I don't know.
And also they will be able to see the recording of this webinar.
Yeah. Sorry, yeah,
in the website.
Mm-hmm.
Yeah.
Okay, so I guess your presentation were as clear as crystal, so no question at all.
However, we are available. You can get our email address and you can come to us and post your questions later on and the next days. And this project is going to end next year, so we will plenty of time to discuss about these issues. And of course, we hope that you are interested. And Tina, would you like to say a few words about the next webinar that we foresee? We don't need.
Yes.
Next
There
year.
is a
There is a question
question.
for me.
Okay.
Good, thank you.
The question is about the concentration of metals in broiler litter. I think cadmium is an example of metals. For Stefan, you have to consider that monodigestion. First of all, there is a topic about the concentration of metals in manure, chicken broiler litter, but also pig slurry, and the concentration of metals depends on the farming side. How much is the integration of minerals in the feeding of animals? With anaerobic digestion, you leads to a concentration of such kind of metals, but anyway, you have to consider the dilution with the digestion with other feedstock. In Italy, we have a regulatory framework for digestate spreading, where there is a limit for concentration of heavy metals or better metals with a potential toxic effect on the environment side. And on my knowledge and survey of digestate characteristic, there are no problem with metals during the co-digestion of chicken or broiler litter for biogas production. Take also in consideration that for the nature of the broiler litter, you need a water for the balancing of the nitrogen content, and as a consequence, a balancing of other metals. So a lot of words, but the point is, at the moment, we don't find problems related to the issue of metals concentration in anaerobic digestion of broiler litter.
Thank you very much. Nice presentation, by the way. Thank you.
Thank you.
So we have another question for Mirko, actually.
So okay. There are two kind of question. One is the pretreatment technologies. Yes, there are pretreatment technology. Think not. Okay, mainly not for broiler litter, but for chicken manure of laying hens, for the content of grit and stone. It's better to add a sedimentation pretreatment in order to avoid to put the grit inside the digester with a potential additional operating costs for the maintenance of the digester. For the broiler litter, on my knowledge, is directly put inside the digester using a solid feeding system or by a mix in a premix tank with other feedstock with a higher water content. About the techniques to reduce the ammonia content in the digester, yeah, there are some innovative additives like zeolite or also biochar, but for zeolite is used also at a real scale, but the effectiveness of the system it depends case by case. The best strategy, on my knowledge, is the addition of some trace metals like selenium in order to facilitate the process biology, and also take the time for the natural adaptation of bacterial at increasing ammonia concentration in the digester.
I think there is another question for you, Mirko. Are you also doing emission measurements?
I gently ask to...
in this project, are you also doing emission measurement from broiler facilities?
Maybe Paolo, because in this project we don't make a measurement of ammonia emission in the farming chicken.
Maybe we can ask Giuseppe Moscatelli, that our colleague who is connected, and maybe we can ask him. He could, if he has experience in measuring ammonia emission in broiler facilities. I know for sure that he did from dairy farms, maybe from laying hens. I don't know if he has experience also in doing ammonia emission measurements in broiler facilities. Giuseppe?
Can you hear me?
Yeah, very clear.
No, in BroilerNet we didn't.
No. I mean, have you
ammonia measurement?
No. I don't think I'm not talking about the BroilerNet. I'm talking about
in other project. Yes, of course, we did ammonia measurement from poultry facility with applying different liter metrics like straw or like straw of rice and other, and also related to the dry content of the litter. Yes, we did.
Yeah, thank you, Giuseppe. It's just,
Yes, if they want, we can give him the link to previous project.
Yeah.
Yes, please. Yes, please share with me the link.
Good. Okay.
And I have a kind of question or just an information that I was working, I was doing emission factor calculation for ammonia from broiler and layer houses by using the Dataman database, which is the global emission factor database from the livestock manures. So what interesting I could find while calculating the emission factor, that we were analyzing the data, and there were studies from 2000 or even late 90s until 2020 or 2021, something like this. So when we divided those studies between the two categories, before 2010 and after 2010, and we could find a significant difference between the emission factors. The emission factors from the studies conducted after 2010s were lower significantly as compared to the studies conducted before 2010. So I was wondering, because in the literature I could not find exactly information about this, but what could be the reason behind this reduced emission? Are these the improved facilities, for example, the improved water systems? Or
Sorry, before the 2010 are higher than
Yes.
after.
Yes.
I think it could be due for the nutrition of the poultry, because in the last decade, more and more has been done for correct the amino acid supply to the poultry, and also to make a nutrient balanced diet, and so are avoid the nitrogen surplus in the diet, I think, and also became very diffused, more of 2 or 3 feeding phase for the
phase feeding.
yes,
Yeah.
and so the nitrogen is more efficiently used for the animal.
Yeah. Thank you so much. Yeah.
Thank you, Giuseppe, and thank you, Vaid, for your question.
You're welcome.
So can you please write down your email? As I think they want to send you something.
Yes, I mentioned already my email.
Oh, okay. Okay, perfect. Okay.
Good.
Okay.
Let's take note of that.
Yeah. Yes. So it was Wumar. Okay. So if there aren't any questions, any thoughts about these topics, okay, I think as Paolo said previously, so in the coming days, you will find information about our next webinar on the website, BroilerNet.eu. It will be held on February the 2nd on this platform, so on Zoom, probably. The webinar will focus on slow-growing chickens and the use of biomethane and carbon footprint calculation. We are trying to define topics for the next webinar, but the poster will be, the flyer will be released in the coming weeks. So please stay updated. We will share the information through our different platforms, so like LinkedIn, via email, newsletter, etc. So I think that's it. So many thanks to Mirko Garuti and Paolo Ferrari for the quality and richness of their presentation. I will send you everything via email, but as I already said, you can find the recording of this webinar on our website. So thank you everybody for joining us today. I hope we see you during our next webinar. So thank you.
Thank you, Tina, and thank you all the speakers. Thank you.
Thank you very much.
Bye.
Bye-bye.
Have a good one.